What we're going to talk about today is multiplying and dividing rational expressions. I want to start with something really simple. Take the fraction 27 over 36. Now, we both know that top and bottom is divisible by 9, and we can divide them by 9 to get 3/4. But if we pulled it apart and sort of just looked at it from a different angle, how about we look at it as actual factors? 27 is 3 times 9, and 36 is 4 times 9. Since our factors are connected by multiplication on top and bottom, it's okay to say that 9 divided by 9 reduces to 1. And what we're left with is 3/4 times 1, or just 3/4. Please take a moment to notice this disclaimer across the top of the screen. That being said, let's take our example to the next level. Now, when we multiply a fraction times a fraction, we merely just multiply across the top and multiply across the bottom and then reduce. But it's kind of silly to turn all of these into huge numbers. It'd be easy to factor, then cancel, and then see what we got left. So 27 again is 9 times 3. And 15 is 3 times 5. 36 is 9 times 4. And 35 is 7 times 5. Now, anybody that can reduce on top and bottom can, as long as all parties are connected by multiplication, which they are. So 9 reduces over 9 down to 1, and 5 reduces over 5, reduces down to 1. Now, I can't cross-reduce across the top, or just anybody on the top can reduce with anybody on the bottom. Nothing else left, so what we have as a remainder, or as a final reduced answer, is 9 over 28. If you've done this correctly, you'll notice that 9 and 28 have nothing in common and therefore cannot be reduced. How does this tie into rational expressions? Well, it's quite simple. We just do what we always do when we see rational expressions. We start to factor. Factoring makes life easy. So what I'm going to do is I'm going to look at the top part and sort of view it as my 27 in the previous example, and I'm going to look at the bottom as my 36, and I'm just going to break them down into factors. I can factor out a 2x from the top piece, or our numerator, and I'm left with x plus 5. Down on the bottom, we factor that best we can. Can't factor out any common monomials, so we split our parentheses up. We notice that everybody's positive, and we put our 3x and x in the front. That gets us our 3x squared. Now I'm looking to have my middle term add up to be 16, so it's very simple to see that we put 5 here and 1 here. The 1 times 5 gives us our 5. We got 1x, 15x, and now we just look to see if anybody's similar on top and bottom. Since this is attached by multiplication and this is attached by multiplication, I can take my binomial that's common in both the numerator and denominator and cancel them out, and I'm left with a final answer of 2x over 3x plus 1. I know just what you're thinking. That was easy. Give me something more difficult. Alright, let's try our example here. What can we factor out of the numerator here? Well, I can certainly factor out a 3x, and I'm left with 1, because 3x divided by 3x is 1, minus x, all over x plus 5, x minus 1. That would give us a minus 5 on the end and a plus 4x in the middle. On the numerator on the top right here, we have x plus 5 and x minus 4. And on the bottom, we just simply have 3x. Now let's see here. If we take our 3x and 3x, that cancels out, and our x plus 5 and our x plus 5 cancels out, and we're left with 1 minus x over x minus 1 times, on the numerator side, x minus 4. But if you take a look at this first term here, it's very close to this. Everybody here is opposite. if we factored out a -1, that would make the 1 a negative and the x a positive. So -1 plus x is the same as x minus 1. So these now cancel out. And I'm left with a final answer of -1 times x minus 4, or negative x plus 4. Either one of those answers is perfectly acceptable. Now, this problem is pretty easy. It doesn't really require a lot of factoring. I would just say that maybe it might be in my best interest to simplify across the top. So I have 48, and then I'm just going to deal with all of this mess right here. I have an x to the 5th and an x squared. It'd be easier just to write it as x to the 7th. And then y to the 3rd times y is y to the 4th, all over. And I'm going to pull this 6. I'm going to take it and put it out front, just so the numbers are up front. I have an x to the 3rd. I'm going to put that underneath my x term. My y to the 4th and y squared becomes y to the 6th. And now it's just a matter of reducing. 48 over 6 simply becomes 8 in the numerator. X to the 7th over x to the 3rd is going to be x to the 7 minus 3, which is x to the 4th. And then y to the 4th over y to the 6th is y to the -2, or better yet, y squared in the denominator. And that's that. Down to our last two examples, we're going to step this up into division. Division is almost as easy as multiplication. It's just one extra step. The first thing we're going to do is factor our first term, 4x, nothing to do there. Pull a 5 out of the denominator, leave us with an x minus 4. Our division sign turns into multiplication, and we're going to multiply by the reciprocal. So our x squared minus 6 plus 8 becomes our numerator, and as it becomes my numerator, I'm going to factor it. That's going to be an x minus 4 and an x minus 2. My numerator drops down to my denominator, and while I do that, I'm going to factor out an x, and that's going to leave me with x times x minus 2. Now again, since everybody across the top is connected by multiplication, it's just one big piece, and everybody in the bottom is connected by multiplication, so that's one big piece, and I'm just going to cancel out anything that's similar. The x minus 2 cancels out the x minus 2. The x minus 4 cancels out the x minus 4. Since the 4 and the x are attached by multiplication, this x cancels out this x, and the only thing I'm left with is 4/5. Done. Now for our grand finale problem, we have a fraction divided by another fraction, all rational expressions. The only uncomfortable notion we have here is that the second fraction doesn't have a denominator, so I just give it 1. This makes it easier when I go to rewrite it as a multiplication problem. Our first numerator is going to factor pretty quickly. 2x and an x. Our 5 is negative, so that we know we have a positive and negative 5 with a difference of 3, which means we don't want to multiply the 5 times the 2. This gives us a 5x and a 2x, a difference of 3x. We want it to be positive, so the 5 should be positive and the 1 should be negative. 5x minus 2x equals 3x. All over 6 times x times 1 over, we'll factor out an x, and we'll get 2x plus 5. Again, since everything's connected by multiplication, I just look at everything up here as one big multiplication problem, and everything is just nice. Alright, well, let's see what we can do here. We can cancel out the 2x plus 5 and the 2x plus 5. And then what? Not much really cancels. So we're going to have an x minus 1 times 1, which is just x minus 1, all over 6 times x squared. In closing, I think you'll find that multiplying and dividing rational expressions is fairly straightforward as long as you know how to factor. Yes, factoring is our friend, folks. So have some fun practicing. See you in class.